Hello, good morning, dear students. Welcome back to Science Tidbits. Today we shall start a new unit, that is unit number 4, Separation of Substances.
Hi friends, today we will study separation of substances. If we closely observe sugar crystals, we will see that the color, shape and size of all sugar particles are same. Since sugar contains particles of only one kind, it is called pure substance. Now on the other hand, if we see soil closely, we will find that soil contains clay particles, grass particles and even some dead insects. Since soil contains particles of different kinds, it is called an impure substance or mixture. Thus, a mixture is made up of two or more pure substances, and the pure substances which are present in a mixture are called components or constituents of the mixture. Most of the things which we use in our day-to-day life are mixtures. For example, tea, milk, seawater, petroleum, air, soil, and sugarcane. The main components present in some common mixtures are as below. A cup of tea is a mixture of several components such as water, tea leaves extract, sugar, and milk. Milk is a mixture of cream in a watery liquid. Seawater is a mixture of water, common salt, and various other salts dissolved in it. Petroleum or crude oil is a mixture of various carbon compounds like petrol, diesel, kerosene, etc. A mixture can be solid, liquid, or gas. For example, soil is a solid mixture, milk is a liquid mixture, and air is a gaseous mixture. Separating mixtures into their components. The mixtures are separated into their components for various purposes such as to remove undesirable component, to remove harmful component, to obtain a pure sample of a substance, and to obtain a useful component. Let us understand this with an example of a tea. We prepare tea using various components like water, sugar, tea leaves, and milk. After the tea is boiled and ready to be served, it is first filtered using a tea strainer to remove the tea leaves, which is an undesirable component. Thus we can say that one of the reasons for separating a mixture is to remove undesirable components from it. Methods of separation. The various components of a mixture have different physical properties such as hardness, density, solubility, size of particles, behavior towards magnet, volatility, boiling points, etc. So when we want to separate the component of a mixture, we should first find out some properties which would be different for different components. The commonly used methods of separations are threshing, winnowing, hand picking, sieving, magnetic separation, decantation, loading, filtration, evaporation, and distillation. Let us discuss these methods one by one. Threshing. Threshing is the process in which stalks of wheat, paddy, etc. are beaten to separate grains from the stalks and from the chaff that covers the grains. Threshing is done by holding the bundles of stalks in hands and hitting them on a hard surface. In this way, the grains are separated from the stalks. Threshing is also done with the help of cattle such as bullock. In this method, the harvested and dried crop plants are spread on the ground in small area, and bullock or other cattle is made to walk over them in circles again and again for several times. Winnowing. Winnowing is the method of separating husk from grains with the help of wind. This method is based on the fact that the husk is very light whereas wheat grains are comparatively heavy. The mixture of wheat grains and husk is taken after threshing in a winnowing basket. The farmer stands at a higher platform from the ground and allows the mixture of wheat grains and husk to fall down from a height by shaking his winnowing basket continuously. The wheat grains being heavy falls vertically to ground, and husk particles being light are carried away by the wind to a greater distance. In this way, husk gets separated from the grains. Hand picking. Hand picking means to take out by hand. The method of hand picking is usually used to separate undesirable substances such as small pieces of stones from wheat, rice, and pulses. The small stones are separated from food grains by placing the mixture on a flat container and hand picking the pieces of stones and throwing them away. Sieving. A sieve is a shallow vessel having small holes at its bottom. The method of separating a mixture by using a sieve is called sieving. Sieving is used to separate those solid mixtures which have a component of different sizes. Such mixture is put in a sieve and the sieve is moved back and forth continuously. The smaller particles of the mixture passes through the holes of the sieve and collects in a vessel kept below. The bigger particles which cannot pass through the sieve remains in the sieve. In this way, the mixture gets separated into two components. Sieves are available in different size holes for separating components from a mixture of various sizes. Magnetic separation. Magnetic separation method is used to separate magnetic materials from non-magnetic materials. For example, a mixture of iron filings and sulfur powder can be separated by using magnet. When a magnet is rotated over the mixture of a sulfur and iron filings, the iron filings being magnetic in nature will get attracted towards magnet, whereas sulfur powder being non-magnetic remains as it is. This way, the mixture is separated using magnet. Also, waste materials supplied to factories contain a number of scrap metals including iron. So, in factories, scrap iron is separated from the heap of waste materials by using big electromagnets fitted to crane. The electromagnet attracts the iron from the heap of waste materials and separates it from the other non-useful waste materials. Decantation. If a liquid containing the suspended particles is allowed to settle in a vessel, the solid matter will settle down at the bottom of the vessels, forming a sediment, and the upper layer of clear liquid can be poured out without disturbing the sediment by the process called decantation. The solid particles which are insoluble in liquid can be separated by decantation. For example, a mixture of sand and water. This mixture is taken in a beaker. It contains sand particles scattered throughout the water. Allow this mixture to settle down without disturbing for some time. The sand will form a sediment at the bottom of beaker. When sand sediments, clear water is left above the layer of sand. Now, pour this clear water gently with the help of glass rod without disturbing the sediment of sand. This process is called decantation. In this way, a mixture of sand and water has been separated into sand and clear water by decantation. At our homes too, when the rice and pulses are washed with water before cooking, then the water is separated from them by decantation. The method of decantation can also be used for separating two immiscible liquids like oil and water. Loading. Sometimes water fetched from river or lake contains very small suspended particles of clay in it. These particles take a long time to settle down on their own. The settling of suspended clay particles can be made faster by the process of loading. Loading is the process in which alum particles are deposited on suspended clay particles of muddy water to make them heavy and settle down rapidly. When a piece of alum tied with a thread is rotated in a muddy water, some of the alum dissolves in water. In this way, the suspended clay particles becomes loaded with heavy alum particles. Due to this, the clay particles becomes quite heavy and settle down at the bottom of the beaker quite rapidly. Thus, the clay particles form a sediment and clear water can be decanted. Filtration. The process of removing insoluble solids from liquids using a filter paper is known as filtration. The mixture of insoluble solids and the liquids is poured into a filter paper cone fixed in a funnel by using a glass rod as a guide. Liquid passes through the filter paper and collects in the beaker kept below. The solid particles do not pass through the filter paper and remain behind on filter paper as residue. The clear liquid obtained is called filtrate. In this way, a mixture of insoluble solids in a liquid is separated into the solid and clear liquid. In science experiments, we use filter paper as filter for carrying out filtration. But in everyday life, different kinds of filters are used. For example, a wire mesh, a piece of cotton, a piece of muslin cloth, strainer, or even a layer of sand can be used as filters for various purposes. For example, after preparing the tea leaves are separated from tea using strainer. This is done through filtration. Also, in many homes, drinking water is filtered by using special water filters made of porcelain, which removes bacteria from it. At water treatment works which supply drinking water to the whole city, the river water or lake water is filtered by using sand filters. Evaporation. The changing of a liquid into vapors or gas is called evaporation. Evaporation is used to obtain a solid substance that has dissolved in water or any other liquid. The dissolved substance is left as a solid residue when all the water or liquid has evaporated. Though evaporation of a liquid can take place even at a room temperature, but it is very slow at this temperature. Evaporation can be made quicker by heating the solution. For example, common salt dissolved in water can be separated by the process of evaporation. The solution of a common salt and water is taken in a porcelain dish and heated gently by using a burner. The water will evaporate and escape into atmosphere. When all the water present in the solution gets evaporated from the common salt, is left behind in the porcelain dish as a white solid. At large scale, seawater is trapped in a shallow lakes and the heat of sun gradually evaporates all the water and common salt is left behind. Here, it is important to note that during evaporation of water solution, we get the only dissolved substance, but water cannot be recovered in this method, as water evaporates in the atmosphere. Distillation. We can obtain salt from saltwater mixture by evaporation, but water cannot be recovered during evaporation as it is lost into the atmosphere. In order to recover both salt as well as water from a saltwater mixture, the process of distillation is used. Distillation is a process of heating water to form water vapor through evaporation and then cooling the hot water vapor to get back liquid water through condensation. Here, we put the salt water mixture in a metal kettle and close its lids. Heat the kettle on a burner. Once the mixture starts boiling and steam starts coming out from the spout of a kettle, take a frying pan with plastic handle and put some ice in it. Hold this pan in slanting position just above the spout of kettle, in such a way that the steam coming out from the spout come in contact with the bottom of frying pan. It gets cooled and condenses to form water droplets. This pure water is collected in a beaker kept below the frying pan. At the same time, once all the water in the kettle boils off, salt is left behind. Separation of mixture using more than one method. Friends, we have studied some of the methods for separating mixtures into their components. Some of the mixtures can be separated by a single method. On the other hand, many mixtures can only be separated into individual components by combination of methods of separation. These methods are applied step by step. Let us understand this by an example of separating a mixture of iron filings, chalk powder and common salt. Here, we will first bring a magnet near this mixture several times. All the iron filings will stick to the magnet and get separated. Then, some water is added to the mixture of common salt and chalk powder and stirred. Common salt dissolves in water whereas chalk powder remains undissolved. On filtering, chalk powder is obtained as a residue on the filter paper and salt solution is obtained as filtrate. The salt solution is evaporated and the common salt is left behind. This mixture has been separated by using three methods of separation: magnetic separation, filtration and evaporation. Saturated solutions. Many substances dissolve in water to form a solution. However, a given quantity of water can dissolve only a certain maximum amount of substance at a particular temperature. A solution in which no more substance can be dissolved at that temperature is called a saturated solution. Thus, a saturated solution contains maximum amount of substance which can be dissolved in it at that temperature. For example, maximum of 36 grams of salt can be dissolved in 100 grams of water at 20 degrees Celsius. If we add more than 36 grams of salt to 100 grams of water at 20 degrees Celsius, then this excess salt will remain undissolved in water. Solubility. The maximum amount of substance which can be dissolved in 100 grams of water at a given temperature is known as the solubility of that substance in water at that temperature. We know that solubility of salt is 36 grams in 100 grams of water at 20 degrees Celsius. Similarly, at this temperature and this volume, different substances have different solubilities. Few examples are as below. Copper sulfate has solubility of 21 grams. Potassium nitrate has solubility of 32 grams. And sugar has a solubility of 204 grams. Effect of heating and cooling on a saturated solution. A solution of the substance in water is said to be a saturated if it cannot dissolve more of the substance in it at that temperature. If the saturated solution of a substance at a particular temperature is heated to higher temperature, then the solubility of substance increases and more of substance can dissolve in it. Similarly, if the saturated solution of a substance at a particular temperature is cooled to a lower temperature, then the solubility of the substance decreases and some of the dissolved substance will separate out in the form of solid crystals. Friends, that's all about the separation of substances. Thank you for watching this video. Hope you liked it. Please do like, share and subscribe to my channel and press the bell icon to get notifications on new videos. Thank you and all the best.